All right, tomorrow in class, we're going to start looking at quadratics that do not have x-intercepts, but they do still have solutions. They would just be what you call imaginary solutions because they don't cross the x-intercepts. If I look at this function, I can see it does not cross the x-axis. So therefore, there are no real solutions. And just like our friends when we were little, we don't have any real solutions, but we do have two imaginary solutions. So what we're going to do is we're going to learn how to work with imaginary numbers, numbers that are not real. If I look at this equation, I can write this in vertex form. So I do that by locating my vertex. My vertex is at 3, so I would write x, opposite of 3 is negative 3 squared, and my y-coordinate of my vertex is positive 1. Remember, you do not change the sign of your y-coordinate. So if I want to solve that algebraically, I would say x minus 3 squared plus 1 equals 0. So now I want to use my algebra just like we did the other day, and I want to subtract 1 from both sides. Notice my 1's cancel on the left. That gives me x subtract 3 squared equals 0 minus 1, which is negative 1. So now what I got to do is I need to get rid of my square. And to undo squaring something, the opposite operation is square root. So I'm going to take the square root of both sides. So that's going to give me x minus 3 without the square equals positive or negative square root of negative 1. Now if you put that into your calculator, it's going to tell you it's an error. And the reason it's an error is because you can never take the square root of a negative number. There's not a real square root of negative 1. So what we're going to want to do before we know how to solve it is we want to eliminate the 3. So we're going to add the 3 to both sides. It eliminates on the left. So that's going to give me x equals plus or minus square root of negative 1 plus 3. And that's really all we can do from there. All right? We need to learn about imaginary numbers before we can go any further. So let's talk about imaginary numbers. Remember, anything to the 0 power equals 1. It doesn't matter what you're raising to the 0 power. I stands for imaginary numbers, and it equals I. It also equals the square root of negative 1. So anytime you have a negative number underneath the square root sign, it's going to be equal to I. I squared always equals negative 1. And then you go through a pattern here. So you get I cubed is equal to negative I. I to the 4th is equal to 1 because negative 1 times negative 1 is positive 1. I to the 5th is the same thing as I. I to the 6th is negative 1. So you start the repetition. Now, in your calculator, when you get to class tomorrow, you can go to mode 2. And mode 2 is the complex mode. And it will work imaginary numbers for you. All right? So if your calculator gives you an error, then you might want to try mode 2. The square root of negative 1, which we've already talked about, is I. The square root of negative 36, the negative sign is the I. And what's the square root of 36? 6. So the square root of negative 36 would be 6i. All right. We want to be able to add and subtract complex numbers. And remember, an I is just a variable. It is a variable that represents the square root of negative 1. But we want to do it the same way we do any variables. We just want to simply combine our like terms. So if this question wants me to add, because there's a plus sign, my first like terms are 3 and 7. So when I add those, I get 10. My second like term are the i's. Positive 2i and positive 5i add to give me positive 7i. So if I add 3 plus 2i plus 7 plus 5i, I get 10 plus 7i. Same thing if I want to subtract. Again, if I want to subtract, I'm going to subtract my like terms. 7 and 10 are like terms. They have no variables. So 7 subtract 10 would give me negative 3. And then I want to subtract my i's, my imaginary numbers. So 3i and 5i. 3i subtract 5i would give me negative 2i. So if I subtract those two, I get negative 3 minus 2i. Again, I can also multiply complex numbers. I do it the same way as I do polynomials. All right, so if I want to multiply 3 plus 2i, I would put 3 on top of my first box and 2i on top of my second box. I would put 7 beside and 5i below. And I simply multiply or distribute, whichever way you like to do it. So 3 times 7 is 21. 2i times 7 is 14i. 3 times 5i is 15i. And 2i times 5i is 10i squared. Now, remember that I squared is the same value as negative 1. So 10i squared is the same thing as 10 times negative 1, which would be negative 10. So I want to combine my like terms. So if I combine my 21 and my negative 10, that gives me 11. And if I combine my other like terms, which would be 14i and 15i, add those together, that would give me 29i. So 3 plus 2i times 5 plus 7i, or 7 plus 5i, equals 11 plus 29i. Let's look at another example. The other example would be 7 plus 3i times 10 plus 5i. So I'm going to take my 7, put it on top, my 3i on top of the second box. 10 goes to the left, and 5i goes on the second row. I want to multiply those using the area model. So I would say 7 times 10 is 70. 3i times 10 is 30i. 7 times 5i is 35i. And 3i times 5i is 15i squared. So again, remember that I squared is the same thing as negative 1. So that would be 15 times negative 1, which would be negative 15. And if I combine my like terms, negative 15 and 70, combine to give me 55. And I also need to combine my i's. So I'm going to add 30i and 35i, and that's going to give me 65i. And you can put that in the calculator. All of this can be done in mode 2 on the calculator. We'll be working on that in class tomorrow. So just wanted you to see how to work with imaginary numbers, and we'll do some more of this tomorrow in class.